Hello, ninth graders. So we are moving on from multiplication of radicals today into division of radicals today. And for the most part, what we see in division of radicals is we just see it as a fraction. So we'll see it as something like 6 over the square root of 3. And that's what we mean by division of radicals, because fractions are really just division in disguise. So the main idea of division with radicals is that we really don't like having a radical in the denominator. Now, there are a variety of reasons why we might not want to, but really the main idea of why we don't want to have a radical in the denominator is because if you don't have one single way to have a problem presented as the finished answer, you have with some questions an infinite number of answers that could be correct. And so we really like to hone in and zone in on one answer that is correct. And what we call rationalizing the denominator, which just means taking the radical out of there, we'll turn it into one fully simplified correct answer that's easy to compare across the board. Now, it's nice for teachers for them to be compared easily. It's nice for you as peers to be able to compare your answers easily this way. It's also nice for mathematicians when they're trying to compare what answers they got with different things, that if you bring it all down to the same type of number, that comparisons are then easier to move forward with. So we have this radical in the denominator, and what we want to do is we want to find a way to get it out of the denominator without fundamentally changing what this fraction is. So what that means is that whatever we do to the top, we have to do to the bottom. Whatever we do to the bottom, we have to do to the top. So what we do know is that when we multiply a radical by itself, it takes that radicand, which is this guy on the inside here, it takes that radicand out and there's no more radical. So I know that if I multiply the bottom by the square root of 3, it'll just become 3, which is nice. It gets rid of the radical. But we need to multiply by what I call a really fancy looking 1, right? Anything divided by itself is just 1. So all I'm doing is making a really fancy looking number 1 and multiplying it to this fraction, because multiplying anything by 1 just keeps it the same fundamentally. So whatever I do to the bottom, I have to do to the top. And I'm left with, remember with multiplying fractions, you multiply the numerator across 6 square root of 3 over, and then multiply the denominator across square root of 3 times the square root of 3 is 3. Now, in order to fully simplify this, we need to make sure that we divide out anything that can be divided out. Remember that when we're multiplying radicals, you can only multiply the pieces that are outside of the radical together and then the pieces that are inside the radical together, right? So I can't multiply something that's inside of a square root with something that's outside of a square root underneath the square root. They have to be kept separate. And it's the same with division. With division, you have to make sure that whatever is outside of the square root can be divided out by anything else outside of the square root. So the 6 and the 3 can divide to become 2, but this 3 and the square root of 3 cannot divide, so it just stays as the square root of 3. And that is the main idea of rationalizing denominators. That's all we got to do, is we're trying to get rid of the square root in the denominator. So we have some practice here. We'll do this first one together on our own. Or together, and then I'll have you do 2 and 3 on your own. So problem number 1, what's in the radical is the square root of 2. So I have to multiply the top and bottom by the square root of 2, and I get square root of 2 over 2. I could leave it like that, or I could write it as 1/2 times the square root of 2. Either of those are correct. All right, go ahead and see if you can do problem number 5 on your own. So our first thought here is that we have to multiply the numerator and the denominator by the square root of 5. And I get 75 square root of 5 divided by 5. And then I have to see, can I simplify this out? Remember that anything that's outside of the radical can divide out or multiply out, but not inside the radical, because this is not in a radical, so it can't divide into here. So we get 75 divided by 5, which is 15, and then we're still left with the square root of 5. Okay, go and do 3. So there are a couple different ways that you could do problem number 3. You could have multiplied by this entire denominator. You could have multiplied the top and the bottom by 3 square root of 6. You would just have to make sure that you fully simplified your fraction by the time you got to the end. What I would like to do is I would like to make it easier on myself, work smarter, not harder. And I'm just going to multiply by the radical because that's really the only thing that we don't like in the denominator there. The 3 there in the denominator is totally fine, right? So I don't really want to try and multiply it out. All I want to multiply out is the thing that's inside of the radical. So remember that I have to multiply things that are outside the radical together and things that are inside the radical together. So since there's only a 4 outside of the radical, I get 4 up here. Square root of 3 times the square root of 6 is the square root of 18. Divided by 3, and then square root of 6 times the square root of 6 is 6. And I have to multiply that 3 and that 6 together in order to do this correctly. I'm going to do a few simplification processes in one step, so pay attention. I've got 4 and then square root of 18. 18 has a perfect square that goes into it. It is 9. The 9 comes out and becomes 3, right? Because the square root of 9 is 3. So I can think about that as 4 times the square root of 9 times 2, right? So that 9 comes out and becomes 3, and it multiplies with the 4. And I'm still left with that square root of 2 because it has to stay inside. And then I've got 3 times 6 is 18 in the denominator. 4 times 3 is 12, square root of 2 divided by 18. And then I'm just going to simplify this fraction right here, 12 over 18. And it becomes 2 square root of 2 over 3. Or you could have written it as 2/3 square root of 2. I would also accept that. All right, so this is the next type of problem, and this is the type of problem that you're going to see pretty much for the rest of your life in mathematics. It is a problem that comes up a lot all the way through your 12th grade year. It's just something that you will see multiple times. We have a radical here, and unfortunately it's separated with a 4 from the 4 with a plus here. And so as we've noticed, having a plus or a minus in your radicals or with many things can get a little bit more complicated than we would expect. I hope that you remember from our previous notes, from our multiplication notes, that when we multiply a radical expression by something that looks like your difference of two perfect squares, that then it gets rid of all of the radicals that are going on in that expression. So what I mean is that what if we multiplied the denominator, instead of 4 plus the square root of 3, we did 4 minus the square root of 3. And it looks like your difference of two perfect squares. And remember that your difference of two perfect squares just ends up being the square of the first term minus the square of the second term. And then it'll get rid of all of your radicals. Whatever I do to the bottom, I have to do to the top. I'm just multiplying by a really fancy 1 here. And so in the numerator, please remember to distribute that 2 to both of those terms. So that's 8 minus 2 square root of 3 over. And then you can even FOIL the denominator out if you don't remember about the square of the first term minus the square of the second term. So you get 16 minus 4 square root of 3 plus 4 square root of 3 minus square root of 3 times square root of 3 is 3. All right, I'm going to combine like terms here, try and simplify it out. I notice that these middle terms cancel out. I still have 8 minus 2 square root of 3 in the numerator. And then 16 minus 3 becomes 13. And for now, I'm just going to leave it like that. We are going to, in future units, talk about how to simplify it out just a little bit further. But for right now, we'll just leave it like that. Okay. I would like for you to try number 5 on your own. So we still want to make sure that we're multiplying by what we call the conjugate. So this guy right here is the conjugate. So the conjugate here is the same terms, 4 and 2 square root of 6. And if it's a minus here, we just need to flip that sign, and so it becomes plus. Whatever I do to the top, I have to do to the bottom. Now I've got in my numerator two binomials, so I have to make sure to do my FOIL distribution. 3 times 4 is 12, plus 3 times 2 is 6, and then that square root of 6 is untouched, minus the 4 times the square root of 5, 4 square root of 5, minus 2 square root of 30. All over. It's going to be the square of the first term minus the square of the second term. Make sure that you square the 2 as well as the square root of 6. So that's going to have to multiply together and become 24. There are no common terms in this numerator. This is square root of 6, this is square root of 5, and square root of 30 cannot simplify out. It does not have a perfect square that goes into it, so it has to stay that way. The only thing we can combine here is the 16 minus 24. So it becomes 12 plus 6 square root of 6 minus 4 square root of 5 minus 2 square root of 30 all over 16 minus 24 is going to be negative 8. We can simplify this further, just one tiny little step. We're trying to simplify this fraction, and I notice that the coefficients in each of these terms are divisible by 2. That can be divisible by 2, that's divisible by 2, 2, 2, and 2. So I can divide all of those terms by 2, which means I can simplify this fraction down. So it becomes 6 plus 3 square root of 6 minus 2 square root of 5 minus the square root of 30, all divisible by negative 4. Crazy. It's crazy looking. Please, please, please remember that when you're dividing these coefficients by a number, you cannot divide inside of the radical because they have to both be inside of a radical in order for them to multiply or divide together. All right. Let's go ahead and try number 6 on your own. So I'm multiplying by the conjugate here, 1 plus the square root of 2 over 3, 1 plus the square root of 2 over 3. I'm going to distribute that 3 to both of those terms. That becomes 3 plus, and then a 3 here and a 3 here cancel out, and it just becomes the square root of 2. Foiling this guy out, or remembering that since it is that difference of two perfect squares situation, it's the square of the first term minus the square of the second term. Square root of 2 squared is 2, and then 3 squared is 9. So then this simplifies down to 3 plus the square root of 2, 1 minus 2/9. You can think of this as 9 over 9, right? So then 9 minus 2 would be 7 over 9. Okay, we need to remember that fractions are just division problems in disguise because we really don't like that we have a fraction here in the denominator. I bet a lot of you are like, ooh, I don't like that. So what I'm going to do is I'm going to do 3 plus the square root of 2. I'm going to represent it as a division of 7 over 9. And if we remember, when we are dividing fractions, we have this thing that we call keep, change, and then flip, where we keep the first term, we change the division to a multiplication, and then we flip our second term, which is a fraction. So now I get to distribute like this. So I get 3 times 9, which is 27, divided by 7, plus 9/7 times the square root of 2. You could have also left it, if we wanted to do over 1 here, as 27 plus 9 square root of 2 over 7. That is the exact same thing.